Assalamualaikum and hi. We Group 1 will be presenting about aluminium coating steel, protection for building steel structure.
Hi, my name is Muhammad Muhairis bin Muhammad Nazmi.
Hi, my name is Muhammad Shekhal bin Sharafi.
Hi, my name is Muhammad Zahid Putra bin Muhammad Zahidi.
My name is Faizakwan bin Faizul.
First, let's look at the background. In the construction industry, structural steel is very popular. Engineers love to use it to build high-rise building and big structures because steel is incredibly strong and can support heavy loads. But steel has one big problem, and that is rust and corrosion. When steel is exposed to weather elements like rain, moisture, and oxygen, it will start to rust over time. If we leave it like that, the steel will become weak and the building can become dangerous for people. That is why we need a good protection system. In this presentation, our team will explain how aluminium coating works as a strong shield to protect the steel, how workers install it on site, and what are the advantage and disadvantage. Next, I will pass the presentation to my friends to talk about the purpose and function of this coating. Thank you.
Now I'm going to talk about the purpose of aluminium coating steel. Firstly is structural integrity, to ensure the steel remains strong and load-bearing over its intended design life by preventing structural degradation. Secondly is asset protection, to protect the investment by reducing the frequency and cost of maintenance, repair, or premature replacement. Thirdly is environmental compatibility, to allow the structure to perform reliable even when exposed to harsh or corrosive industrial environment. And finally, thermal management, to improve the building energy performance by reflecting heat, which help regulate internal temperature. Next is the function of aluminium coating steel. Firstly is barrier protection. The primary function of aluminium coating is to create an continuous film that physically separate the steel surface from corrosive agent like moisture, oxygen, and chemical. And then finally, inhibited layering. The primer layer, zinc bridge, serves the function of an electrochemical protector, while the aluminium top coat provides UV resistant and high reflectivity barrier. That is all for me.
Surface preparation. The integrity of any protective finish is forged in its initial moment. To achieve an enduring bond, the steel foundation must be flawlessly prepared. The surface preparation phase is more than just a basic cleaning. It is a vital process of clearing the state. Every square millimeter of the raw steel surface is meticulously treated to remove every trace of rust, deeply embedded oils, stubborn grease, old paint, dust, and industrial condiment. This process utilizes a precise multi-stage cleaning protocol. First, chemical degreasing solutions are applied to break down stubborn, complex compound that regular cleaning cannot touch. Once cleaned, the steel is completely dry. This step is critical, as eliminating residual moisture prevents it from disrupting the upcoming coating process. Finally, the steel undergoes abrasive blasting using sand or steel grit under high pressure. This intense operation does not merely clean, it engineers a specific microtexture on the metal. This rough texture creates 1,000 of microscopic anchoring points, allowing the aluminium coating to bond firmly to the steel surface. By investing this level of detail into preparation, we ensure maximum adhesion, improved durability, and long-lasting corrosion protection. Fluxing. With the steel surface purified and structural texture, it enters the critical fluxing phase, the invisible architect of the final metallurgical bond, while the initial cleaning removes the heaviest contaminant. Bare steel can deform microscopic oxidize incredibly fast when exposed to air. To combat this, the steel is thoroughly dry and completely immersed in a specialized flux solution. The purpose of this flux bath is threefold. First, it actively removes any remaining oxidize on the surface, preparing the steel perfectly for its upcoming coat. Second, it creates protective barrier that prevents any new oxidation from taking place where the metal is deep. Most importantly, this flux layer significantly improves weighting between the molten aluminium and the steel. By allowing the liquid aluminium to fuse seamlessly with the steel substrate, it ensures a highly uniform, durable, and continuous protective layer, eliminating potential defect during the dipping process. Hot dip aluminium. We have arrived at a definitive transformation, the hot dip aluminium process. The clean steel member is carefully and gradually lowered into a bath of pure molten aluminium maintained at a searing temperature of approximately 680 to 700 degrees Celsius. To achieve total coverage, the steel is fully submerged, so the liquid metal can wrap around the entire structural design. During the intense immersion, a profound chemical reaction takes place at the molecular level. The aluminium reacts directly with the hot steel surface. Instead of just sitting on the top of metal like pin, an exceptionally strong aluminium iron alloy layer forms right as the core interface. As the part is withdrawn, an outer layer of pure aluminium develops over this alloy layer. The exact characteristics of this protective shell are detected by immersion time. By carefully calibrating how long the steel remains submerged, calculated according to the steel thickness, the overall member size, and the required coating specification, we can tailor the final result perfectly. What remains is a seamlessly impenetrable layer that provides effective corrosion protection and a powerful metallurgical bond.
After the steel has been immersed in the molten aluminium bath, it is carefully removed and allowed to cool. During this stage, any excess aluminium drains off the surface, while the remaining coating begins to solidify. Depending on the manufacturer's process, the steel may be cooled naturally in air or by water quenching. Cooling is an important step because it allows the aluminium coating to harden and form a strong, durable protective layer. Proper cooling also helps prevent coating defects such as cracking, peeling, or uneven surfaces. Once the steel has reached a safe temperature, it is ready for inspection and handling. The next stage is inspection and quality control. This ensures that every coated steel member meets the required specification before it is delivered to the construction site. There is 4 inspection process. The first inspection is a visual inspection where the surface is checked for defects such as bare spots, crack, bubble, or incomplete coating. The coating should appear smooth, continuous, and free from visible damage. Next is an adhesion test. May also be carried out to verify that the aluminium coating is firmly bonded to the steel surface. A strong bond ensures that the coating will not peel or flake off during transportation or service. Next is the coating thickness. The coating thickness is measured using a coating thickness gauge to ensure it meets its required standard. The coating must be thick enough to provide effective long-term corrosion protection. If there is any defect are found, The affected area are repaired before the steel is approved for use. Only steel members that pass all inspection requirements are transported to the construction site. Now I will explain about the advantages of using aluminium coating. The first advantage is an excellent corrosion resistant. Aluminium naturally forms a thin oxide layer when exposed to air. This oxide layer acts as a protective barrier that prevents moisture, oxygen and other corrosive substances from reaching the steel, making it highly suitable for coastal, marine and also industrial environment. The second advantage is long service life. Aluminium coated steel can provide protection for several decades, depending on the environmental condition. This reduces maintenance requirements and also lower long-term costs. Another advantage is high temperature resistant. Unlike many paint coatings, aluminium coatings can withstand elevated temperature without losing their protective properties. This makes them suitable for industrial building and structures exposed to heat. In addition, aluminium coating forms a strong metallurgical bond with the steel during the coating process. This bond is much stronger than a conventional paint coating, making it more resistant to peeling, cracking, and mechanical damage. Aluminium also requires a low maintenance because the protective coating remains effective for many years. This reduces repair costs and extend the overall service life of the structure. Lastly, is its aesthetic appearance. Aluminium coating provide a clean, uniform metallic silver finish that enhance the appearance of exposed steel structure. This attractive finish often eliminates the need for additional decorative coatings or paintings while still providing excellent protection.
Thank you to my teammate for explaining the advantages. Now, let's look at the limitation or disadvantages of aluminium coating steel. First, it has a high upfront cost. The machinery and materials used in the factory are quite expensive. So, the initial budget is higher compared to using normal structural paint. Second, it makes welding harder. If workers need to weld the steel on site during installation, they must grind off the aluminium layer at the joints first. If not, the welding will become dirty and weak. Lastly, there is a risk of cracking. If the factory makes the coating layer too thick, the layer can become brittle. This means it can crack easily if the steel bends too much. So, engineers must balance these pros and cons before choosing this technology. I will wrap up our presentation with the conclusion. To conclude our presentation today, let's review the main points about aluminium coating steel. In short, protecting structural steel is very important in construction to make sure the building is safe and lasts long. As we discussed before, aluminium coating is a great solution. It forms a strong layer that shields the steel from rust, rain, and even every high temperatures. Of course, it has some disadvantages like higher cost at the beginning and harder welding works on site. But if we look at the long terms, it is totally worth it. It can last up to 15 years without needing any repaint or heavy maintenance, so it saves a lot of money in the future. As a future construction professionals, understanding this technology helps make better choice for building modern structures. That's all from our group. Thank you very much to Madam and everyone for listening.